Hello guys, David Vose here. Boy, it's a beautiful day. Nice, beautiful sky and fluffy clouds, and I hope you're having a wonderful day. The old doggies are out laying in the sun, and the chickens are picking bugs off the ground, and everybody's happy, except the bugs, I guess. But, today, I was telling you yesterday that I was going to try to do the video today about the new revelation I had on this. I guess we'll call it this infinite plane theory. 2 nights ago, I was walking in the middle of the night out here, and it was real early in the night, so the sun had only gone down an hour or so before. But I'm walking along, and I had this revelation about some things that I've already had revelations on. And one of this is we've talked before about how things converge in the foreground. And I did eventually get AI to admit that. And now they're readily admitting that. It's like they're learning. Oh, Dave's on here again. We better not try to lie to him about that one. We already told him that. So we've established, A and I have established what we already thought we knew. That two parallel lines that go in the distance will eventually somehow converge in the middle in some distant place, perhaps at the horizon or something. But what's interesting about that is that is the up and the down converging at the horizon. And I thought, well, just like a mountain that might be 10,000 feet high and 2 or 3 miles wide, the whole thing looks like a little inch square in the distance, 50 miles away. That couple of miles is now shrunk down to this inch. So the convergence doesn't just happen from the top and the bottom converging into the middle, like two parallel lines that are vertical. But if you took those parallel lines and made them horizontal parallel lines, they would also converge. And so therefore everything around you would converge like a cone, right, into the distance. And so I was thinking about that while I was walking. And I thought, well, and I thought of this before, but I was kind of going further with this, that if the sun was going overhead, then as it went into the distance in the west, going down across the sky, it would always appear to go straight. It would come up in the east and go down in the west, even though we were on an infinite flat plane and the sun was actually going around like a ball on a tether pole. Now, hold on, because some of you are probably thinking, wait a minute, you're saying an infinite plane? Well, if the sun's going around an infinite circle around us, how does it come back in 24 hours? And, how does it light up the whole infinite plane? Well, we'll get to that here later, but understand that our sun is only for this area on the infinite plane. Just a little radius of 6,000 miles, something like that. And beyond that circle or radius of 6,000 miles, there would in the distance be another star that would light up there, that part of the infinite plane. So you would go out of the range of our sun, and you would then go through a very cold place, like maybe the Antarctic or the Arctic, because there's no sun there for a while. And then boom, you'd start getting warmer, because now you'd be going into another land where they have their own sun. And these suns would then be like Venus, which wouldn't be a planet necessarily, or it would be one of the stars. And you say, yeah, but those stars look so small, they must be way far away, and there's so many of them. What's going on? Well, we'll explain that. There might be an infinite number of spheres out around this sphere we live in. And so there would be quite a few of them that would be about the same size around the peripheral in the distance about 6,000 miles from wherever we are. And then beyond that, there would be more stars, right? Quite a bit, maybe they would look smaller than those stars. And then another group and another group, all in an infinite bunch of spheres all out there in the distance. However, because of the convex shape of our eyes, when we're looking straight up at all these stars, it appears to be all up above us, you see, but it's actually down at the horizon above the infinite plane going out in all directions. Well, I'll get to that later, but we're talking about the sun going around our neck of the woods on the infinite plane in this circular arc, like a tetherball, going around and around above us. So if you were laying on the ground looking up at this tetherball going around this pole, and somebody hit the ball and went around and around and around and around, and you were looking up, you would see the ball go around and it would arc around in a circle because it's right there close to you. Now, keep in mind that half of this arc is going to be on a yearly basis. Half of the circle is going to be winter and half is going to be summer, because this sphere is going to be oscillating. It's going to be moving to the north for us in the summer, and it's going to be moving back south for them in the winter to create the seasons. And it's going to be positioned so that when it goes overhead, it's closest to us, and that's where there's sunshine. But as it goes further and further away, say towards China, then we don't see the light anymore. So it gets dark. So the sun then would be closest to us during the day and further away during the night. It would be closer to China for them while it's night here. And that would happen every 24 hours because that's how long it takes for that thing to go around in that circle above us. However, remember, at night, the moon's going to come around. And the moon is the same size as the sun, but it's not as bright. And we're going to show later on, I'm not going to do it here, that the sun's not on fire. It's simply a big object, maybe about the size of the Earth. I mean, it could be any size. We have no idea. We're living on an infinite plane, the Earth. The Earth's not a globe, as they say, but I mean, we could just imagine this big globe about the size of what they say the moon is or something. Maybe bigger, maybe smaller, we don't know. Perhaps all these things are the same size, but because when it gets close to us, it causes a static charge, and that's what turns the lights on, both on the Earth while we're looking around down here and everything's charged, and therefore the little like a balloon, you get close to your hair and your hair stands up. It's charged. The little lines go straight up and down. That's light. But when it goes further away, then the static charge goes down and your hair falls back down, or the little lines go back down to vertical, and then it's dark. And the moon comes around, and because it is made of something different, or, well, briefly, a battery has two electrodes that conduct electricity. We have the positive electrode and the negative, two dissimilar metals. So the sun and the moon would be two dissimilar electrodes or conduits. And the Earth, or the infinite plane, would be the battery holding the charge. And when the sun, being the positive electrode, is near us, then it would charge the Earth to a light, to be light, and would be charged. But when it went further away and the moon came along, that would be the negative electrode. So rather than giving energy, it would be more or less giving us the opposite of energy, or making a very faint glow, because it's the negative electrode. We'll talk about that later. But let's get back to here, to what we're talking about. Keep all of that in mind as we're going on here. However, if the sun is far, far away and the Earth is thousands of miles, or our region of Earth in this infinite plane, then if the sun went and it was going in an arc, it would apparently move towards the center as it went forward in the distance. And therefore it perhaps, because I don't know the exact math, perhaps it would appear always to be straight. If it was, say a few thousand miles in the distance, then it would certainly, because we're only supposedly seeing 3 miles to the horizon, which is completely crazy to me, as we talked about the other day, because if I'm standing here looking 3 miles to the horizon, I turn around and it's 3 miles to the other horizon. That's only a 6-mile frame of reference that we're able to see. And yet the sun comes up over the horizon and travels 12 straight hours that we see it in the sky. And we're only seeing 6 miles of the Earth. And I thought, well, if it's 93 million miles away, maybe. If it's a globe, then yeah. But if it were an infinite plane, and if it weren't that far away, it's nothing's working right here. It should take, if you were on a flat plane, 5,000 miles on the flat plane. But you couldn't see that far because of the parallel lines going and converging, and everything would converge in the center. Now, I don't know how far that would be from where I am, where everything would converge. But I would imagine it's more than 3 miles, right? It would seem like it'd be more than 3 miles, but I don't know. But if it were only 3 miles, then it seems like the sun would only be up in the air for an hour or so, right? Because 3 miles, if the Earth is 24,000 miles around, then, it would only work then on their little globe model. And then I'm just saying maybe it would work on that model. It doesn't seem to work on that, the distance and the time. And then I thought, well, wait a minute. If what I was saying before, and the sun is really curving like an arc on a tetherball around a pole, then I would see apparently the sun just going straight. And where it would go apparently off the east-west line and start going north to make that curve looking west, it wouldn't go straight in actuality. It'd be going around in an arc, and it would be going north. So though it would be going around in a arc or a circle above me, I would see it apparently going straight across the sky east to west. During the time, the 12 hours, because that's the only time I'm seeing the sun is during those 12 hours of daylight. And during that time, it would have to have made a full half an arc. But it would apparently look like it was straight. Again, why? Because as you look in the distance, everything converges to the center. So even though the sun is actually going around in an arc and veering off to the left or something, we don't see it going to the left. Because as the sun goes away from us, further and further away, it's converging towards the center. Our peripheral view is converging into a cone. It's literally going around curving towards the north, but it's far enough away where we don't see that curve because our line of sight, those parallel lines are going in and converging somewhere on the horizon, and everything's converging at that small little point, and we never see the curve. And that would explain then why we only see 3 miles in the distance, but we could still see the sun. And this is why the sun just always looked like the same size. In fact, if anything, when it gets to the horizon, it even looks bigger. But why, when you see the sun going over, and it takes 12 hours, the first 1/8 of the way, it just goes quickly. Within an hour, you start to see the sun come up over the horizon, and within an hour, it's already gone 1/8 the way across the sky. It's like whoop, whee, And same thing in the other direction when it goes down. The last 1/8 of the sky, just really quickly, it goes down within an hour. But you still got 10 hours where it's up there in the sky, which is, if it's only gone 1/4 of the way, real quick, then you have to travel this entire 3/4 of the way in 10 hours, but 1/4 of the way in an hour or so. And that the timing doesn't seem right. Now, if it is like they say, and it's 3 miles to the horizon either way, the sun's in the sky for 12 hours. When we see the sun going down real fast, that would be the opposite of what it should be doing. Because if it's going into the distance, way far away from us, and it's still going and going and going and going, it should take longer, that last 1/4 of the way going down over the horizon, because that should be a long way in the distance, because we're only seeing 3 miles, and obviously the Earth is more than 3 miles, so it should be taking hours, that last little bit. And the only time that we should see the sun in its brilliance at the heat of the day should be a couple hours going across this 3-mile area. But far in the distance, it should take hours to go, because it definitely, the sun's up for 12 hours, but we're only seeing 6 miles. So that last 1/4, maybe, 1/8 of the way, where it goes so quickly, perhaps the reason it goes so quickly is because as it's going and doing that curve towards the north, like a tetherball, maybe that sun's not 93 million miles away, but it's just shining on an area like the size of the United States, Argentina, or this side of the globe, the western part, and it starts going towards China, and China's only, a few thousand miles away, 5 or 6, 7,000 miles from here. And so it's not 93 million miles. So it and the 3 miles that we see it, where it takes 12 hours, we're not seeing it go 24,000 miles around the other side and come back. That's a long ways, right? So that last little eighth of the sky isn't really the last little eighth of the sky. That's really all the way around and halfway up to the north, because it's making that arc. And so that long distance, we don't know where that distance is. We see the sun the whole time. It's up in the sky for 12 hours from where we're at, because it's only going like a couple of thousand miles as it starts bending around and turning back towards the northwest, and then the north, and then the northeast, and it's going around. So it's really not that far, right? So it's really spending the whole 12 hours just kind of up above us, and we see the whole thing, and it's taking all this time, but it arcs around. So let me show you here something. We're going to make this circle about what they're saying. That's Bolivia there, where the equator is, and it goes through the northern part of Africa. It might be, maybe it should be a little smaller. We've got to follow these grid lines, to be fair. So it would have to be something like that, give or take. So there would be how the sun goes around on a flat Earth. But we have seasons, and so the sun would be going up here in the summer, and it would be down here in the winter. So it would have to move throughout the year, just slowly move the circle, and it would eventually be up here, and then it would go back down here, and it would just be going back and forth. But let me show you something on the globe model about that. Now, on the globe model, you see the Arctic Circle, Tropic of Cancer, Equator, Tropic of Capricorn, and Antarctic Circle at the bottom. So the way they have it is that the sun is going around this line all the way around, and from the back, and comes back around again. And this happens, this is where the sun's going around in the winter. In the spring and the fall, it's going on this line and going around, you see. And in the summer, it's going on this line and going around. Now, the reason that it does that, because they're saying it's on an axis that's tilted, and therefore, at some time of the year, the axis is over here, see? But at this moment, it's here. Now, when it moves over, then this sun that's way out here, that's shining down here, would now be over here and shining this way, you see. And this is what makes the sun go around here in the winter and here in the summer and here during the spring and the fall. And therefore, it would be just back and forth, turn, as it goes around the sun, around the sun, when it gets to the other side of the sun, this axis is over here, and now it's shining over here, and this earth is spinning round and around. This earth is spinning around and around 24 hours and 365 days this way, and it's making this apparent winters and seasons. Well, it makes sense. But notice this here would be the Tropic of Capricorn, and this would be the Tropic of Cancer. And then, according to them, then they would have a circle that would be circumnavigating the globe this way and around and back to the other side. And down here, it would be around and back to the other side. This would be a distance smaller than this, you see. And that would mean that, let me show you on the other map. That would mean that these circles would be like this size, right? In the northern hemisphere, this size in the southern hemisphere, and yet during the spring and the fall, it would be too small. It would have to be a bigger circle. Now, how would you do that? How would you have a bigger circle? Well, you could do that on this flat Earth model, because the circle could actually, literally get bigger and then go back down to smaller and then go back up to bigger. I mean, that's possible if the reason why it's going around is a vortice, and I'll explain why there would be a vortice, like a hurricane above us, only it wouldn't be a hurricane, a low and a high pressure of air causing storms and violent behavior that's going in weird, oblong and crazy, unpredictable ways, but it would be a much more higher vortice made not of wind, but of radiation or light or something that we couldn't see or feel, that was always very uniform. But it could, though, be a bulge and kind of go back and sway to the other side and then come back and sway to the other side. And since hurricanes are smaller at the top and larger at the bottom, then as they go up this vortice, they could actually change size. AI says, yes, a hurricane, its structure, and this would be the same for the kind of vortice that we're going to be describing here, that it's not going to be a wind vortice like a hurricane, but it'll be a higher frequency vortice that we will describe at some other time. But just to get an example, a hurricane structure can become asymmetrical and change over time. And the bulging you're describing is a known phenomenon that is related to the storm's overall dynamics. It is part of the storm's complex internal process, not a simple low-pressure, high-pressure seesaw. Here's a breakdown of the atmospheric science at play. Asymmetrical structures. Hurricanes often have an asymmetrical structure because of the interactions with the environment, such as variations in wind shear or land and ocean surface effects. Vertical wind shear, when a hurricane moves through an area where wind speed or direction changes with altitude. This can push the storm's top in one direction. This creates a sloped eye wall, where the eye is not perfectly vertical. The boundary layer and asymmetries. The interaction between a storm's circulation and the underlying ocean surface creates inflows in the boundary layer, the lowest part of the atmosphere. This inflow can be asymmetrical, which then causes the wind and the thermodynamic structure of the storm to develop asymmetries. As the storm moves, these environmental interactions can change, leading to the kind of shifts you described. The eye wall replacement cycle. A storm's internal dynamics can cause it to develop multiple concentric eye walls. The inner eye wall then collapses and the outer one moves in to replace it. This process can cause fluctuations in the storm's intensity, as well as shifts in its overall size and structure. These atmospheric effects can produce the visual perception of a storm bulging and changing shape at the top as it progresses. And it would be very reasonable to think that if it's moving from the north to the south and from the south to the north because it's winter or summer, that while it's moving, it might be literally moving further up slightly because of whatever upper pressure or low pressure. It would be moving higher and upper this cone. And it literally, the circle would be changing its dimension or radius. However, if we use a globe model, it wouldn't really work. And here's why. Let's go back to the other picture. Because they're saying that this sun goes around here for a month or so, and it starts moving up, and then it's going around this way, and then in the winter it's going around here. This is further. And the only scientific reason they say is that the Earth is a globe, and the Earth is going around the sun, which is over here or something, and this thing's going around, around the sun, and it literally, because of it's on its axis, it's wobbling, back and forth 23.5 degrees, and this is what's causing the warp. But it would literally speed up only in your eyeballs perspective, since the sun's not really going around the Earth's going around the sun. So there would be no mathematical necessity on this globe model to understand why this is a further distance right here than this or this, because it would take longer for the day in the summer to go and shorter for the day in the winter, which would match what they're trying to say. It's just this illusion because of the tilt of the axis, I guess. So, okay, maybe it works on the globe model. I mean, probably works. They got all kinds of ways to make excuses, and well, there's an angle, or there's a shift, or there's an axis, or there's a something, right? They can come up with a model that maybe works, but does it work on a flat Earth model? So this is where the circle goes around on the flat Earth model. But because we've got the seasons, winter and summer, we know that it's got to go up for a while for the summer and down for the winter. Well, when it does that, then it's not going to rise on the equator every day exactly at 6 a.m. and go down at 6 p.m. because it's moving a little bit, right? There's this 23.5 degrees, it's moving like this. So how do we explain the fact that the sun always comes up at 6 and goes down at 6 on the equator? Or does it? Because if it does match, in other words, if it's not exactly 6 o'clock, but in the winter it's a little bit less than 6 o'clock or a little bit more, then we could probably prove that this is what's going on. Let me show you what AI says, guys. Oh, buddy, watch this. And you'll be surprised to find the answer, because I didn't know this. And this might give some impetus to the idea that was correct. That's how the sun works, because it says no, the sun does not rise and set at exactly 6 a.m. and 6 p.m. on the equator throughout the year. while it's very close, with about 12 hours of daylight and 12 hours of darkness each day, several astronomical factors cause minor variations. Well, that's what we'd have to have. There'd have to be a minor variation if that circle moved a little bit north and moved a little bit south so that we could have winter and summer. So this is matching up real well. Why sunrise and sunset times vary slightly at the equator. Elliptical orbit, Earth's orbit around the sun, is not a perfect circle, but an ellipse. Well, that's what they say. I don't even think we're going around the sun. I think the sun's going around above us, right? Because of this, Earth's orbital speed changes, and they got all these excuses and angles and elliptics and all kind of gymnastics to figure out why this is going on. See? The width of the sun, the atmospheric refraction. Oh boy, right? But the key takeaway is the length of daylight on the equator is consistently very close to 12 hours, but it varies. So that would probably, I'd have to dig into it a little deeper to see if it worked mathematically perfect. But it does seem to vary, and that would give us room then to go back to what we were saying. But understand, we can understand with what we said why it would vary at the equator a little bit. It wouldn't always be at 6 a.m., but it would be close. Might be 6:10, 6:15, something like that, but somewhere around 6 o'clock. However, it would not work on the globe model because they have to use gymnastics to explain it. But that couldn't be possible. But think about it. If the globe, as they believe it to be, was on an axis and spinning every 24 hours, then the equator being a round equatorial circle that faces exactly the direction of the sunlight that's beaming down, then if the Earth does take 24 hours, then contrary to what they're saying about refractions and winds or elliptics or whatever, it would have to, because it's spinning and the shape of the Earth doesn't change, it would always be an exact certain number of hours. It would be 24 hours every day in the spring and the fall. And since we have a clock that starts at 6 and ends at 6 in the evening, it would have to come up exactly at 6 and go down exactly at 6 every day in the spring and the fall, or at least at the very spring equinox and the fall equinox. On that day, it would have to come up at 6 and go down at 6, period. But it don't. There's variations. And the reason there's variations is because, as we've said, it's not going around a globe, it's going around an infinite plane. And there's a vortice that has a bulge. It goes to the north in the summer and it bulges to the south in the winter. And therefore, that tetherball sun going around this infinite plane is going to move back and forth between spring and winter. And on that equinox day, or that spring or fall equinox, it's not going to be exactly 6 o'clock a.m. or p.m. because that circle's moving, as we showed. And I think that might give one a lot of evidence for the flat Earth model. And if that's true, let's go to the next part of my demonstration today. And so I thought I'd ask AI if it would do that. Now, I asked AI a couple of questions, and they answered me. And like we talked about the other day, they'll continue to answer the questions until they get stuck, and then they disappear your question and say, oh, I forgot. I don't know what you asked me. Ask me again. And you just typed out this long thing, and then you got to retype it. And you do it once, and you're not pissed off. But the second time, you're like, oh, man, AI, you're doing something here. You're manipulating me. And I confront them, and they're like, oh, no, we didn't. They're all lying. And I've noticed it every time. When they get to a question they can't answer, they cut me off, and they just don't answer it. So today I asked them about this, and I tricked them. But I don't have it to show you because they disappeared it. But what I did was I got them to say, because they know and I know that the sun's straight. We don't see it curving arcing towards the north. It just goes right straight from east to west. So they know that. And I said, well, on a flat earth model with a ball going around a tether pole, like I've described to you guys, wouldn't the ball appear to converge in the middle, just like the mountain, the sides of the mountain, the two parallel sides, points that are actually several miles in width? Wouldn't those two parallel lines, if they ran all the way to me, appear to converge in the distance? Because they apparently do, since that several miles of the mountain base turns into an inch in the distance. Wouldn't that mean then that the sun would appear to go in a straight line? And they said, oh yeah, the sun does go apparently in a straight line. And I had them admit that. So then I asked them, well, then doesn't that mean that if we were on a flat plane and the sun was going overhead, it would in actuality be going in an arc, but it would appear to be a straight line? And then that's when they realized that I had gotten them, that I had gotten them to admit that what we're seeing in the sky because of our convex eyeball is that things in the distance appear to be converged into a central point, and this is why the Earth appears to be round, and it's also why the sun appears to go overhead from east to west in a straight line, but it's actually going in an arc. And this, as we go further today, I'll explain why. This also explains why if you go in the north and look up, you see the North Pole and the Polaris star in the North Star. But if you're in Australia or Argentina and you look south, you see a completely different star because of this convergence that we're going to talk about here in a little bit. I'll try to explain that. So they got caught in a lie and they quit. They just quit. I think it's a little bit like Jehovah's Witnesses, that they won't put anything in print. They'll tell you something privately, but they won't put it in print if they don't want anyone else to know. It's like legal things that they can't say, right? They can do word of mouth amongst the brethren, right? So everybody knows what they're supposed to do, but they don't want that in print. Like if they were going to tell everybody, hey, don't take blood transfusions or something, and that was against the law because it could kill somebody. They're like, well, just privately tell everybody don't do it, but we'll never have it in print anywhere, something. So it seems like AI is doing that to me. They don't want me to have anything that I figure out and I prove to them, and they've actually stated it themselves. They have to disappear it so I can't prove that they said it. So I went ahead and asked the whole thing over again, and they didn't answer me again, which proves that they don't want to answer it because I'm right. So this is what I said. I said, oh, I see. You conveniently disappeared our conversation again when you had no answer. I asked if the sun was going around a flat Earth model, like a tether ball around the pole. Would the sun appear to go across the sky as a straight line and not a curve, because the principle that the further anything goes distant, it converges toward the center, and the two parallel lines seem to converge in a point near the horizon. So the actual arc of the sun around the flat Earth would appear as a straight line. And then crickets, nothing. They just show me a few links on YouTube, Facebook, and Quora, when where people are talking about the flat Earth, and they don't discuss this issue. So they just don't answer me. And in every other case up to this point where I got them, they answered. And their last answer did prove that I was right, but it's disappeared. So guys, this is proof. It's proof for me because I'm sitting here. May not be proof to you guys because maybe you don't believe that I'm doing this or that I'm telling you the truth. But I just said what I said about this, and now I went ahead and asked them again, can you answer my above question? And it was there. I just read it to you. I didn't go off the page. I didn't refresh it. Right? And I just typed in, can you answer my question above? And they said, of course, however, I can't see your previous question, so please type in again for me. Just paste or type it in, and I'll be happy to help. Well, they just disappeared it. And it was such a long, beautiful question, and I'd have to go back and try to write it again. I'll try one more time, guys, but I think they're going to disappear it again, which I think indicates maybe we're onto something. Let's see. So sure enough, I wrote it out again. Couldn't remember what I'd said before, but I did read it to you here. But this time I said, and please don't disappear it this time. You do this every time I ask something you don't want to answer. If the sun was traveling across the sky on a flat Earth model, would it not appear to travel straight in a line from east to west, just as we see it? Because two parallel lines always appear to converge in the middle after some distance. So the actual sun's motion would be a curve or arc, but would appear to be straight west. And crickets again. Quora, YouTube, Facebook. The same three things they showed me last time. It's just some flat earther talking about stuff that has nothing to do with what I'm asking. So I think this is some kind of, I don't know if it's proof, but it's some kind of, they've done this every time now when I get to a point that they either don't have an answer or they don't want to answer. Now, it's not like, I know some of you might be thinking, well, there is no answer because they go by a globe model and there is no textbooks or anywhere to draw from for this model. But I'm not asking them, unless this is what AI is, only a machine that can gather what other people have written before. But it seems like they can put words together, and if they're going on our past conversation, we've already talked about this, and they've already given answers and said yes or no or whatever, and it sounds like they can do this. But it's just conveniently they don't answer me. So I think what we've got here is a match. It appears that this is something that is apparently true. If it was just completely apparently not true and provably not true, then AI would easily give me an answer and show where I'm wrong, but they won't show me where I'm wrong. Now, we could take a little look at this Quora and see if they answer this question. They say, how do flat earthers explain the sun emerging from horizon to the east, moving in a parabola and hiding beneath horizon to the west? Is it like going below the disk? Then why day and night time vary in different countries? They say day and night time vary in different countries because the sun does not rise due east and set due west in any country. It does so only on equinox. Here is the direction of the sunrise and the sunset in Rome. So this is not what we were talking about. If the Earth is really flat, why can't we see the giant ice wall? So this is just talking about flat Earth, but it's not answering the question that we had. So, well, in fact, here we've got both questions where I say, can you answer my question above? And they say, of course, however, I can't see your previous question. So I went ahead and wrote it out, and look, they don't give me an answer. So they're not wanting to answer me. I'm going to say that is a fact. That if you look towards the west and watch the sun going down, it is going to appear that it is going straight across the sky from east to west, and you will not see the curve because as it goes further in the distance, it converges into the center line. Now, that would be a fact that everything converges. The only thing we don't know is whether or not you would see any movement or, the exact dimensions and all of the exact math. We might need a mathematician. But I think just from common sense, we know that 50 miles in the distance, this 2 or 3 mile width of a mountain ends up being 1 inch. So if the sun is thousands of miles away, it certainly, as it goes into the distance, would just, even though it's going around this large curvature and the arc, it would just appear to be straight. So we've got other things to talk about. We've got to talk more about what I was talking about with the two electroids, the sun and the moon. I want to talk about the sun not being on fire, nuclear explosions or anything like that. It's simply an object that is of greater weight or mass than the moon. Now, that doesn't mean the moon isn't great weight and great mass, just like you can take aluminum and copper. Those are two dissimilar metals, and you can stick them into the earth and get a volt. Because they're dissimilar, you're going to get a flow of electricity. So if the sun was any slightly different than the moon, it would be the positive electroid, and the moon would be the negative electroid. And that would mean that when the sun is going around in this vortice, the moon would be pretty much on the opposite side. But because they are dissimilar, then it would be the sun, as it got close to us, that would create the positive charge and light up the earth. And we would see the sun as a very bright light, like a light bulb, right? And yes, it would be also apparently heating the earth, vibrating the molecules, or however we want to describe this energy or vibration. And when it went around and got away from us, then we would quiet down and cool down, and the moon would come around, and the moon would be the negative electroid, which would be a negative, meaning some other kind of blue light or different kind of light. And people have said that is indeed what the moon is doing. Remember, the moon and the sun seem to be the same size. They're probably flying around up there about the same height above us at different opposite directions in this circle. Now, why would that be? Because just like the model that they have of electrons, electrons going around a neutron, you got a proton, an electron. So this would be, it's just a model that they draw because they know about this whole high pressure, low pressure, male, female, negative, positive. This is just a model. But in actuality, it is what is going on with the sun and the moon. But now, why is it that the sun is always bright when it's near us, but when it gets farther away, we can't see it at all? See, it's not, we'd probably be able to see the sun the whole 24 hours, except for that as it gets further away, it no longer has the direct line or conduit, so that it just goes off, the light goes off, and we don't see the sun anymore. Now, that's possible. And as it gets further away, the moon comes around. And now the moon, why is it that we only see the moon like half a moon, a quarter of a moon, crescent moon? Well, that would probably be because the moon is oscillating every 30 days back and forth differently than the sun, which is oscillating between a 360-day period, making the winters and summers. And the reason why the sun might be doing a 360-day oscillation, but the moon may be doing a 30-day oscillation, waxing and waning, could be because this vortice that's around that we talked about, where we talked about the eye wall and the bulge, and it's going back and forth. And it talked about how the center rings inside this vortice will exchange with the outer rings. And so it could very well be that the sun occupies the outer ring of this vortice, and the moon is a little bit interior in the inner ring, which has a different pull, a negative pull. The outer part of the vortice would have a positive charge. It would be putting energy into the earth, and the inner ring is like the inside of a hurricane pulls stuff up and spits it out the top. So there's a positive and a negative, in and out. And so the moon is that negative energy coming out. It's pulling energy out of the earth. And since the earth is not as charged as the sun, then the energy it's pulling out of the earth is less energy. So think about it this way. The sun is above, and it's the positive. So energy is coming from the sun into the earth, charging the earth bright. And you see that bright sun because it's positive. And because the sun is on the outer ring of this vortice, it's that positive charge. Now, inside the hurricane, there's another swirl, but that's the negative. That's the pull, not the push. And so the moon is in the center, in a smaller vortice in the center. Therefore, it doesn't take 365 days to oscillate, but only 30 days. It's a smaller circle inside the vortice that's pulling or sucking everything up from the earth. Like a hurricane sucks things up, like Dorothy's house, right? Right up in Toto, too. But so that pull is the negative charge. And it's not a bright light, but it does pull energy and causes this negative gray light. I think that is what's going on with the sun and the moon, but we're going to leave it there. We're only about 50 minutes, but I'll go ahead and leave it there because it's getting dark here and I got to get this loaded. But I'm going to continue on with this probably in a upcoming video, and we're going to continue on talking about all of these particulars. Anyway, I hope you enjoyed that and it made sense. And the Lord loves you guys. You know that. He loves everybody. Just seek him and start preparing because things are going to start going down. Anyway, we'll see you guys tomorrow. The Lord loves you. His grace and his peace be with you. We'll see you. Have a good one.